Greetings and salutations, mathletes. I apologize for my absence today, but today we're going to move forward into the notes packet. I would like you to know that because of my absence, our test was supposed to be on Monday, November 5th, and now it will be on next Wednesday, November 7th. So next Monday we will review in class, and next Wednesday we will take our last unit test. As far as the quiz goes, we'll probably get that back during our review class or the next time that I'm with you. So the substitute should be checking your day for homework. And I would like you to think about these three problems. You can write them on one of your homeworks, but the first one is a true or false question. The second one is asking you for a missing angle measurement. And the third one is a 5-letter acronym from our last class. Please pause the video and try these. I repeat, please pause the video and try these. Thank you. All right, so in the first example, it says true or false, reflecting over a point is the same as reflecting over a line. So I've drawn the reflection over the line DCE. If I reflect over this point, okay, A would still go to A prime because it maps directly over that. But B, if I counted to here, I would have to go that same amount to right there, okay? So the answer to this is false. If I'm reflecting over a point, it's the same as a rotation of 180 degrees around that point. In the second problem, they're telling me two triangles are congruent. And they tell me M is 50, which would make T 50. They're telling me L is 20, which would make S 20. And if they want angle U, it's the same thing as angle N. I would subtract these values from 180. Okay, and in the last problem, all right, I have to prove the triangles first, and then I can use CPCTC, which stands for corresponding parts of congruent triangles are congruent. Okay, so looking at our last homework, we did a little bit of this in our first unit. So you were trying to figure out what angle measure this is. I'm just going to keep scrolling down. If any of these you are confused about, please circle them so I can go over them with you when I am back at school. Okay, and one thing to remember, if you don't draw a picture, okay, these have to come in order. So M and P were the first and the last. That means I want X and V if it is going to be corresponding. Okay, CPCTC is basically saying once I have two triangles that are congruent, that means the rest of them, all their parts have to be congruent as well. So this is what's new. If you see we end in angles or sides, you know this is going to be CPCTC. And before that step, we have to have that the triangles are congruent to each other. So if I'm looking at my givens, this is my perpendicular symbol. That's where those two came from. I need two steps for that. So in my proof, that was steps 2 and 3. 1 and 2 are right angles, perpendicular forms right angles, 1 and 2 are congruent, all right angles are congruent. If we ever see parallel, so that's here and here, we're trying to draw the Z. So that gave me these two angles, I called them 3 and 4. Okay, I've said parallel lines mean that the alternate interior angles are congruent. And once we've used both parts of the given, then we look for reflexive or vertical. This has the reflexive property. So this would be angle, side, angle. and then we finish with CPCTC. The other thing we went over last class is if I'm given that these two little angles are the same, the sides across from them have to be the same. So that's step 3. They use if base angles of a triangle are congruent, then the legs are congruent. If you just said if angles of a triangle are congruent, the sides opposite are congruent, that works as well. This example had vertical angles in it, called them 1 and 2. And then in my given, they told me those sides were done. So this is side to angle to side. And then we can finish off the proof with CPCTC. All right, so I'm gonna have you go to page 30 in your notes packet. I'd like to go through this proof with you and write it down. Um, all right, so my first suggestion is you label the picture from what it's telling me are my givens. So if the big triangle is isosceles with A as a vertex angle, the vertex angle is between the two congruent legs. So this is going to lead me to AC equals AE. The next one tells me that I have midpoints, okay? So if these are the midpoints, I'm going to split that into 2 equal parts, all right? And since I knew this whole thing is congruent to that whole thing, these also have to be congruent, because if I split 2 congruents into half, the halves have to be the same. They then tell me CBD equals here, and they're asking me if B to D is congruent to F to D. Okay, so just so we know when it ends like this, we know we're going to have to use CPCTC. The other way it would end is if the triangles were congruent. All right, and because it is isosceles, I also know the base angles are congruent. So I'm going to be able to prove that C is congruent to E. And then I have angle to side to angle. So I'm going to show that these two triangles are congruent by angle, side, angle. So I'm going to write out all the steps. I'm going to see if you can fill in any of the missing reasons. Okay, so I tried to color code what I underlined in the givens and where my statements came from. So the 2 statements in blue come from the idea that ACE is isosceles and A is the vertex. Okay. The 4th step in green comes from the idea that B and F are midpoints. The 5th step is something new. Okay. So if I knew AC and CE were both 10, the midpoints would split them in half into 5s, and then I know all the 5s are the same. So halves of congruent segments are congruent. Should make sense if I take half of 2 things that are congruent, they have to be the same. So one should try and pause the video and fill in the missing reasons. Really, pause the video and try and fill in the missing reasons. So the 2 blue ones come from an isosceles triangle. So 2, I said the legs of an isosceles triangle are congruent. 3, you could have said the base angles of an isosceles triangle are congruent. If you forgot that, I'm saying that 2 sides of a triangle are congruent. Then the angles opposite them have to be congruent. The next one I use is midpoint. So midpoint splits, midpoint divides the segment into 2 congruent parts. Then we have our halves of congruent segments are congruent. Again, that came from step 2. Then we said they're congruent by angle, side, angle. And every time we prove 2 triangles are congruent, the next step is always CPCTC. And just as a reminder, we're trying to build your tolerance to see, what are the statements and reasons. Most of all of my statements are two things are congruent, and then my reasons are why those two things are congruent. So next, just to give you an idea of what a multiple choice question will look like in our test next Wednesday, try page 31, number 6. So I'm glad this one gave a picture, all right? If it says DAB is congruent to CBA, I always should have some highlighters or some extra things to write out. Some people like to pull them apart. I'm sure it's exciting that that spells dab. Less exciting that it spells cab. Okay, but if I follow, all right, D came first, C came first, A came second, B came second, B came third, A came third. Okay, so these are like a reflection of each other. At the same time, I'll know that these sides all have to be the same. Okay, so by knowing that, I can now decide which one of these has to be correct. So B to D is not the same thing as C to D. DA is not the same thing as DC. BCE doesn't correspond to DAB. So ACB, which is here, has to correspond to BDA, which is there. Okay, so that just gives us an idea of what a multiple choice question would look like. All right, so I'd like you to turn to page 33, and I'd like you to give this problem a shot. I'd love it if you paused it, okay? And I'm going to list out what I think is the proof for this. All right, so here's a hint. This proof can be done in two ways, okay? We have to remember if it says bisect, whatever comes after bisect is what's getting split, all right? So this segment from A to E is getting bisected into two equal parts. All right, so that gives us one of our sides, okay? Now, every time we see parallel, you probably want to try and trace a Z. So if I trace that Z, I could say angle B is congruent to angle D. And technically, I could also do this reverse Z and say angle A is congruent to angle E. Now, if I do that, I am going to have angle connects to angle, which connects to side, okay? So if I did that, I would have an angle, angle, side, okay? But some people will notice that I have vertical angles here. So you could say angle 1 is congruent to angle 2 because vertical angles are congruent, okay? And then technically you could have angle, side, angle. Or you could still have angle, angle, side, okay? So this kind of depends what you want to do, all right? But if I go A to B to C, I have to make sure that I'm using the proper order. So A corresponds with E, B corresponds with D, and C to C. All right, and then our final step, I'm not numbering anything depending if you use vertical or not, is CPCTC. Okay, that's a pretty standard proof right there. Okay, so the last thing that could happen is we could use two triangles are congruent to show that more triangles are congruent. And this is rare to show up, but this could be like a 6-point problem that we'll definitely practice. Okay, Tom Brady probably had his way with the Bills. It is what it is. Um, but if I'm looking at this, all right, they're telling me that D to P and F to P are congruent. D to M, M to F are congruent. All right. My goal is to show that DME is congruent to FME. Okay. And there's probably a few ways to do this. All right. But the quickest way to do this is to show these two triangles are congruent because I already have parts of them. The last piece I could do is the reflexive property. Okay, so if I do reflexive here, then I can show these triangles are congruent by side, side, side. Right? Notice that that's already a piece of the green and blue triangles. So I could do reflexive for the green and blue triangles. Okay, and then the only angle that they share in common would be here and here. Eventually they would have to be right angles, but I don't have to say that. So if I proved angle 1 and angle 2 by CPCTC, then I can do the big triangles by side angle side. All right, so I'm going to write that out. Again, this is a longer type of proof that we might have to do, but hopefully you can follow it along with me. Okay, so typically this is how our proof would go. I'm saying PM is congruent to PM. That's the reflexive property. All right. Notice I did DMP and FMP. That order matters, but this is by side, side, side. And then after I prove triangles are congruent, my next step should always be CPCTC. Now in the big triangle, I have to say that EM is congruent to EM. Again with reflexive. You could have done this earlier in one step. And then that finally brings me to those two big ones are congruent. Okay, and again I have side to an angle to a side. Okay, so sometimes we use congruent triangles to do CPCTC to find something that comes next. All right, so the last thing I want you to do is if you flip to the very last page of the packet, it should be blank. Okay, we're just going to practice something on that blank page. Okay, so I want you to read this problem and see if you can figure out what they're telling me. So vocabulary is very important here, just like sound quality is really important if you're going to be a YouTube star. So if they're telling me the legs of a triangle, those are the two congruent pieces, right? The bottom is called the base. The angle at the top is called the vertex angle. The more you write this down, the more you will remember it. So if I know that these are 3x plus 4 and 10x minus 10, then I can set 3x plus 4 equal to 10x minus 10, which is typical if we're talking about sides. If I was solving this, I would subtract 3x and add 10 to both sides, and then divide by 7. Okay, and then I want to reread the problem because they don't always end with x, they want the length of the base. So if I want the length of the base, that means I need to put 2 back into there to get my final answer. Okay, so I did make a video about hypotenuse leg. I did not have the headset that I'm wearing right now, which that audio quality though, dot, dot, dot. When you are done with this, please raise your hand to get the homework. Okay, again, you're just doing your best on this. Thursday is going to be a practice day, and next Monday we will review. Next Wednesday we will take our test. I hope this was better. Thank you.